My dog Coco and I are going to try to help you with the discussion board assignment on stereochemistry of pharmaceuticals. We'll start by copying the name of the drug that we're going to use. And then in Marvin's sketch, we're going to paste it. Use the select tool to select the structure. And then rotate it. Remember, you want a bond to be in the straight up and down position, so I'm selecting this one off the chiral carbon. The way things are now, I've got kind of an ugly group here in the 4 o'clock position, so I'd like to flip my structure here, and I'm going to do that with the edit, transform, and flip, and I'm going to choose to flip this horizontally. Okay, so with the select tool, I'm just going to click here in the white space. I want to get this to be a wedge, and I'm going to need to put a dash in also. So I can go to my bond tool and select the wedge here for this one. And now I need to get a dash in here and put that on the same carbon. The default for Marvin sketch is to put a CH3 at the end of the bond, and that should really be a hydrogen. I don't want to throw a carbon in there, and that'll fix that. To get a more acceptable presentation here, I'm going to move some of these groups just a little bit. I'm going to bring my OH group just down a little bit. Still, it's in that 4 o'clock position, and then I'm going to put the hydrogen just behind here. It's just more conventional representation of the tetrahedron there. It's all downhill from here, folks. This is actually going to be easy now. We've got our chiral center with the bond in the 12 o'clock and the 8 o'clock. These are in the plane of the screen. And we've also got this OH group as a wedge coming out at us, and then the hydrogen is in the back. And now we need to select our structure. And then choose copy. And paste it. Put it right in here beside our other structure. Try to line it up. Let's select the structure that we just pasted in here. And we'll go to edit and transformation, and then we've got this really handy mirror, and we're going to mirror this structure horizontally. And now let's get our RS designation in here. I clicked in the white space, and under view we go to the stereo RS labels, and let's get them all labeled. And you can see we've identified this chiral center as being R, and this chiral center as being S. Now, if you went through all this and you end up with two that are R or something, you did something wrong, probably with the mirror feature. Taking a moment to review the RS designation here, our highest priority group is this OH group, and we've got our lowest priority group back here with the hydrogen. So we move from the highest priority group to the next highest. Now the next highest group would be this one right here, since it's got the oxygen connected to the benzene ring here. This one has just an oxygen and a hydrogen. So we move from this direction to this direction, to this direction, and you can see we're going in a clockwise circle. So this is R. Likewise, when I move from the highest priority group to the next highest priority group, I'm moving in a counterclockwise on the S. The last thing we need to do is to represent our mirror plane, and I'm going to use a line to do that. Draw it right in the picture where the mirror would lie if these two molecules were to look at each other. And why don't we give that mirror a little color? I think a nice silver color, something like that, would be good for mirror. And done. Save this as an image and post it to the discussion board.